All right, everyone, welcome. Hi, my name's Adam. I am a software engineer at Spotify. This is a tiny little sliver of a TypeScript workshop that I like to give at Render ATL. Just a little amuse-bouche on a few TypeScript features that I happen to love that are not well understood or well appreciated. So here goes nothing. Unions and conditional types. I have some long-form blog posts on both of these. If at any point you're like, hey, I want more time on that, check them out. Aaron has these slides. They're public. I'm sure he'll tweet them out or something. So check it out if you want more. Let's lay a little foundation. If you didn't know, TypeScript is structurally typed. I'm not going to call on anyone, but show of hands, who is confident that you think you know what that means? If I ask you, what does TypeScript being structurally typed mean? All right, cool. This is going to be great. No, that's good. Well, now we're going to leave this room knowing that. All right, so nominal typing is sort of what you're used to if you've used any other statically typed language like Java or C#. Like when you assign a type to a variable, that variable has to hold that type or something that inherits from it. Structural type, we just care about the structure of the type. Any 2 or 3 types are equivalent as far as TypeScript is concerned, so long as the structure of those types is the same or equivalent or compatible. Sometimes called duck typing. This is OKC. I'm guessing there's some C# developers in here. Here's some C# code. If you have 2 classes that happen to look the same but are different, you can't assign them interchangeably. It doesn't work. But in TypeScript it does. Any 2 types, you can just swap them out however you want, so long as the types hold the same structure. And you can even assign just a raw JavaScript object literal to a variable that's typed to hold a class if the structure matches. And the reason for this is because TypeScript is just some types that are bolted onto JavaScript. And so you see a lot of JavaScript's heritage with some of the design decisions that went into TypeScript. All right, so unions. You can declare a type that's a union, which just means 2 or more types. It means that any instance of this type is either of the types that we've assigned it. It can be a string or a number. And so this leads to some surprises and some frustration. I know there's a lot of code up here, but we've got a type called square, we've got a type called circle. I've created some instances of it. And then at the very bottom, I hope you can see that, we created a variable that's a square or a circle, and I'm going to assign it to a square or circle randomly. And now a lot of people get mad when they hit the dot down at the bottom. They say, all right, some shape dot, and they think, well, it's a union of square or circle, so I'm just going to get all of the properties that are in squares or circles. And they get really mad when it's just that one, just the description. They're like, hey, I want all the square properties and all the circle properties. Why am I only getting description? Description's the only property that's in all of them. And so it seems weird, and I've seen senior level engineers complain about this on Twitter. They're like, oh, TypeScript's badly designed. I'm like, no, it's a skill issue. and here's why it does that. When you tell TypeScript that a variable is A or B, it doesn't know which it is. And so it's only going to let you access the properties that it knows are safe. If it doesn't know whether it's A or B yet, so it's only going to let you access the stuff that's in both A or B. So what do? You have to narrow it. Narrowing is a huge topic in TypeScript. If you have a union that's A or B, you have to narrow it down to A or B or C or D, however big the union is. And there's a bunch of ways to narrow. This is like an hour of my workshop. But here's just 2 fun ways. One's a little surprising. Anyone ever see the in keyword in JavaScript? It's old legacy stuff, but it's still there and it still works. And you can actually just see if a variable has a property in it. And the really mind-bendy thing is that TypeScript is actually keyed in here. And TypeScript is going to analyze your code, and it's going to say, oh, if inside of this if block, there's a length on this object, only squares have a length, so I'm going to narrow this to a square. And inside of this if block, some shape is now a square. So TypeScript actually reads your code, and inside of these control flow blocks, it will change the type that a variable is declared as, which I've never seen that in any other language, and I've used a fair number of them. And in the else, it's not a square, so it must be a circle. This is a fragile change. This is a fragile solution. It just happened to work out because there's this length property that's only in squares. The better way is to just change the types. What if we add a new property to this type? In TypeScript, types can hold literal values. You can have a type that is only the string square, which seems pointless. You can also, on the circle, add this property that's only ever going to hold the string circle. And then when we declare the variables, we have to add them, which is annoying, but it lets us narrow our types by checking that type property. This type property is usually called a discriminator. It discriminates between types in a union, which is why this is called a discriminated union. And on to conditional types. I want to do just a minute or two, literally, of live coding. What's a conditional type? Well, in TypeScript, you can say, we'll create an isArray type, and it's going to be generic. Conditional types are almost always generic. And we can ask questions about our type. We can say t_extends, if I can type, t_extends array of any, and now I have a true block and then a false block. So it's like an if-else, but we have to use the ternary syntax, and it's only the ternary. You can't do an if-else. I said types can have literal values, so let's do true and false. So I'm going to pass some type to this, and I can just run code inside my type declaration. I can say if t extends an array, true, else false. And now if I do something like this, now I can use the type, right? I can say isArray string, it should be false. What about isArray string array? And now it comes out true. Cool. That's pretty useless though. I already knew that a string array is an array. What if I say isArray of what? I want to pass in a string array and I want to get string back. I want to see what is an array of. So conceptually, what we're thinking is, well, is this an array of some other type? And then kick that type back to me. And then we'll say, I haven't told you what never is, don't worry about that. And TypeScript's yelling at me. It's like, hey, there's no you. You can't just make up variables and stick them in. We're trying to infer whatever this variable is, but it's not declared, so we just tell TypeScript, well, infer it. So if t is an array of this thing, infer u, kick back the u. And now, when I say of what, it should give me string. And if I pass it a non-array, it should give me never. And this rabbit hole goes deep. You can like nest these ternaries and ask subsequent questions. You can say, is an array of what? So like an array of string arrays. Like I want to reach down twice and get it. So okay, this is an array of something. That something, is it an array? Does that you extend an array of infer v? Give me the v, else never. And if I did that right, it'll give me the string. And these get really gross, and these ternaries can get nested, and people get angry about it, but it's a handy tool to have in your toolbox. And let's wrap this up. I showed you that. It turns out those conditional types, they have quirky behaviors when you use them with unions. They combine weirdly with those unions that I just showed you. Here's a type. We want to get a description of some type that we pass in. If it's the square that I showed you, we'll get 4 sides. Again, that's a literal type. Pointless and silly, but it'll show us how this works. Else, if t extends circle, we'll give it round. And if it's none of the above, we'll say dunno, I don't know. What if we pass a union type in with that? You would think it's going to just do nothing, right? Because this union type doesn't extend square, and it doesn't extend circle, so it would be dunno, but it kind of feels wrong, right? Square or circle, it extends either of those. Anyway, the way TypeScript actually handles this is it breaks up the union, and it runs this type for every value in the union. So if I pass in a union of square or circle, first it's going to run it with square, and it's going to give me this guy. And then it's going to run it again with circle and give me that, and then it's going to union together all of those results. So if I ask for the description of square or circle here, it's going to give me 4 sides or round. That's really useful, and you can do cool stuff with that. And I'm 20 seconds early. All right. Thanks for listening, everybody.